Okay, today I'm going to talk to you about specific latent heat. So specific latent heat is basically all about the amount of thermal energy required in order to change state. So remember, what changing state either means is melting, boiling, condensing, or freezing. So let's just have a quick recap about what's happening on a kind of atomic level when we're talking about changes of state. So let's say here I've got a substance. These are different molecules of that particular substance. Between those molecules, there are these forces that are called intermolecular bonds. So these are bonds in between these different molecules. In order, let's say if this was a liquid here, in order for this liquid to turn from a liquid to a gas, I'd need to break these bonds. And energy is required to break these bonds. So I need to heat it up, put thermal energy in, and break these intermolecular bonds so this can turn from a liquid to a gas. So there's actually an experiment that we can do, and the results really help us visualize what's happening. So what we can do is if we get a Bunsen burner here, let's say, and on the Bunsen burner I've got a beaker, and within the beaker I have lots of ice. What I can do is I can actually heat up the ice and then read my temperature change on a thermometer. So I'm also going to need a stop clock right here. So here's my stop clock. So what I'm going to do is I'm going to start heating up my ice in my beaker, and the second I do, I start my stopwatch. Then what I do is every 20 seconds, I'm going to record the temperature on my thermometer, and I should be able to plot my data on a graph. Now, this is what your data should look like, roughly, from this experiment. So you'd plot temperature on the y-axis and your time on the x-axis. What you should find is over time, it starts to rise up here. Now at the beginning, in fact, I'll draw the shape first. So this is what we should find. It should look something like this. Now let me explain what we're looking at here. Now, this is the temperature of the ice at the beginning of the experiment, okay? So this is my temperature of my ice, which is obviously a solid. So when I'm heating up the solid, there's more energy is going into the kinetic store of these particles because they are vibrating more. The more energy we give them, the more that they vibrate. Therefore, the temperature increases. Now, this is the bit that's a little bit strange. As the ice starts to melt, we do not have a temperature rise. The reason for that is all of the energy is going into breaking the intermolecular bonds within the ice. So therefore, we get this flat section here where the temperature does not go up because all of that energy is going into breaking bonds instead. Now, once all of that has melted, we then have an increase in temperature again. This is when we have water, because it's all melted, it's all now a liquid. So again, we have an increase in temperature here, because now it's water, liquid, we're again just putting more energy into the kinetic store, or the thermal store of the water. Now, when we get to this point here, again, we have another flat section. This is when boiling has happened. Again, we're not having a temperature rise because all of that energy is going into breaking the intermolecular bonds between the water molecules in order to turn it into a gas. So this is when boiling is happening. And finally, this section shows steam, which is obviously a gas. So what specific latent heat actually means, it's the amount of energy required in order to get 1 kilogram of a substance, so 1 kilogram of a substance, to change state without an increase in temperature. So it's basically, we're thinking about these flat portions of the graph here. That is what specific latent heat is all about. So, yeah. The next thing we need to know is we just need to know the equation associated with specific latent heat and how to use it. So here it is right here. Q equals M times L. And here's an equation triangle that kind of shows that as well. So Q stands for thermal energy. So this is the thermal energy that would be put in order to change state. The M is simply the mass of the liquid that we're changing, which is measured in kilograms. And finally, L, that stands for specific latent heat. Specific latent heat. And that unit for specific latent heat is joules per kilogram. So let's just imagine this. Let's say that we're told the specific latent heat for water is 334 joules per kilogram. You don't need to know this number. You'd always be given a specific latent heat. Your question might be, how much thermal energy is required in order to change the state of 500 grams of water? And then you'd be given this value here. So all you'd need to do is use this equation. Now please notice, this is in grams, we need to convert to kilograms. So you'd have to do this, 500 divided by 1,000, which equals 0.5. So to find the specific latent heat of this substance, you'd simply do 0.5 multiplied by 334, and let's see what that would give you. 167. So the amount of thermal energy required in order to change 500 grams, change the state of 500 grams of water, would be 167 joules. So the final thing we need to know is just two more terms. So there's two different types of specific latent heat. If we're talking about either melting or freezing, this is called the specific latent heat of fusion. And if we're thinking about boiling or condensing, this is called the specific latent heat of vaporization. And a final point, a lot of people get specific latent heat and specific heat capacity confused. A nice little way to try and remember which one's which is latent has got 8 in it, and so does state. So this one is about changing state. And that is about it. Thank you.